Hello, hello, and thank you for taking your time to listen to this presentation. The title for this presentation is The Quiet Blend, made by Paulos and Edward from Georgia State University. Let's begin with the introduction. Do you ever wonder why there are blenders that make so much noise? Or do you ever have to use a blender in the morning and realize you just wake up everyone in the house? If you say yes to this question, then we agree with you. Blenders are used for many things, and we realized for this group project that was under $15, a blender would be a great idea to find a way to reduce its noise level. How we start with this project was first by examining the blender from outside and inside. We disassembled the whole blender almost under 5 minutes. The process may vary between any type of person that does this type of job, but the difficulty measure for us from 1 to 10 was a 3. What we found inside the blender was a motor connected to a motherboard with also a battery inside. We examined the inside of the blender to figure out a way to silence the blender. The tools used for this project was a Phillips screwdriver, a flathead screwdriver, and these tools were the only things used to be able to look inside the blender. Now moving on to data collection method. Our method was to be able to measure the noise of the blender by using a certain type of measuring tool. We decided to use the decibel meter. By using a mobile app called DecibelX, we were able to measure the noise level of the blender. This app was very accurate, and with no charge whatsoever. The reason we chosen to use the decibel meter was for its function to measure vibrations from any type of machinery or any other thing that produces vibrations. We realized that is what exactly the blender does. It releases vibrations. Now moving on to data analysis. Let's start with this, and we measured the noise level in 2 different ways. The first blend was running with fruit and water, and the next run was with basically nothing. As the results with this experiment, from the images you can see here, we got close measurements from the decibel meter, and we discovered in this experiment the main noise of the vibration is coming from the motor shaft. So our analysis that we concluded and decided is by reducing the noise by the motor shaft, we'll be able to reduce noise from the blender completely. And from here in the images, you can see the measurements that we actually received. Now moving on here to production function model. This is just how the function model is for the blender. It is quite simple to understand, but important to remember. Now moving forward to improvements. Since vibrations from the motor shaft was the main reason for the noise at the blender to be so high, the team decided to purchase a tape that specializes on reducing noise and vibrations. We made sure this tape was also heat resistant to not have any issues in the future. The results were effective, but at the point where we thought it would land at, not so sure it really didn't happen. The noise and vibrations were only reduced by 3 decibels. We know it's not a major improvement, but it's the start of something that can actually work with some time put on. In summary, the blender noise was able to be reduced. Even though it wasn't a major reduction, we realized that the blender works perfectly with this adjustment, and the silent tape sort of works. The tape itself cost over $199, and with estimation of we made to see how long this tape can last, we realized probably 5 more blenders can receive this tape until running out. We believe this improvement work, but there is room for more improvement, of course. Here's a reference if you have any more questions. And thank you for your attention. Have a great day.